Hello, everyone. This is October the 5th of 2022, and welcome to the KMM community meeting. We will have a reduced attendance today from the Red Hat team, mostly because today is a bank holiday in Israel. But hopefully we can still discuss a few topics that we have on the agenda for today. I would start first with an announcement, the announcement that we now successfully have configured upstream builds for KMM. So those builds are triggered on each commit to the main branch of the upstream repository, and they end up in this Google container registry that belongs to the Kubernetes project. So this is the image name. It contains only the operator. We do not have bundled builds yet. And as you can see, it has the latest tag. The image name has the latest tag, and that is different from what we have in the getting started instructions of the repo here. So if you try to run that command right now, kubectl apply-k, that will not work, unfortunately. So we are working on getting that resolved. Yeah, as soon as the PR is merged, then that should be fixed. Still, we have the infrastructure in place and the builds are going. So hopefully that's already a start. I guess that's it for the announcements. Any question on this? No question. So I would jump to the first issue that was created in the sorry. Yeah, I thought someone was talking. All right. So I would get started on the first issue that we have for today. That was created, I think, by someone from Intel in the downstream repo of KMM, and that's about the SC Linux type that we give to the module loader pod when creating the daemon set. And Hirsch, are you here today?
Yes, I'm here.
Hello, Hirsch. So do you want maybe to give a few words about the context of this problem?
Yes, sure. So in our understanding right now, looks like both the KMMO upstream as well as the downstream repo for the module loader daemon set, it uses the SC Linux option SPCT, which is the super privileged container type. And we think that may be overprivileged to insert and remove the out of tree kernel modules. So we wanted to know if there is a way for, if there's an interface provided in the module where the user could try a more custom policy that would be tighter. So that's something we wanted to discuss with the community.
Right, thank you. So we gave this some thought, and so there is no way for you currently to customize that type through the module CRD. There's no such field. But we were especially, wondering what's the use case behind that, because you're anyway loading a kernel module, which will run as super privileged code on the system within the kernel space. And so does it make sense to restrict what modprobe can do if anyway you will be running something that will have kernel privileges and permissions?
Quentin, this is about SE Linux policy, and it's kind of a little bit different with root privilege in the host operating system. Actually, if you are using the SE Linux on your system, actually there's a several layer of security mechanism. SE Linux is I think is the first layer, and they use a label to control. Provide a fine control to some array resources on your host operating system. And then if you go through this SE Linux policy control, and then you go into the traditional Linux root user and group control. So actually, that the reason we filed this issue is that we met the similar issue when we are working on the Intel Intel device plugin operator And when we first run our operator on the OCP platform, we looks like that we have to, and also we are suggested by the Red Hat that we should use SPC-T policy. And according to our investigation, we find that actually the SPC-T policy actually is a super privilege, which means that although Linux provide a mechanism to contribute to some fine control to every resources, but with SPC-T, actually that this policy bypass all of this kind of control, and actually the user can do everything to the host. So that is not safe for us. So it's specific to our case, like I mean the KMMO case, even we need to assign their demo set to the privilege or permission to ins mode and R mode, the kernel module. But that doesn't mean that it can do everything. So we should define, or we should firstly find an existing policy. That's already some predefined policy in Linux that can restrict the user's permission to access the host from container. That's the first thing. If we cannot find a usable, available policy to use directly, maybe we have to define our own policy to restrict the user's permission. The reason we need to do that is that the fine control of the security control of the host operating system is very, very important for the security point of view, and we want to limit every system level service permission. We do not want to give them their super privileged permission. And also internally, I can say internally, Intel also has our own SDLE policy rules before we release everything. One of the key rules is that we should not avoid the super privilege permission to adding service. If we can avoid it, we should not assign this policy, this super privilege permission to the service. So that is the background why we filed this issue. And actually that our team already worked with Linux maintainer Dan. We spent several months to figure out the detail how to do that, and successfully file a tailored policy for the Intel device plug operator. I think that we should do the same thing on the KMMO if user use KMMO and Linux at the same time.
Right. So I would, I hear what you say, and I would differentiate, the device plugin and the module loader here. Device plugin ultimately is something that runs in user space that needs indeed high permissions because it will connect to the Unix socket to the kubelet. So it does need some permissions to actually mount the var lib kubelet device plugins or some directory and create Unix sockets in there. But that is still user space, and I agree that we should try and contain that as much as possible, including with SE Linux policies. Now, if we're looking at the module loader, we are doing something extremely privileged, on purpose. We are loading kernel modules, which is already, extremely sensitive, because once you're in the kernel, you can do whatever you want. You can even disable SE Linux. So if we would customize, my understanding at least is that if we would customize the policy for the module loader, it would restrict what the user space process is able to do, and that is mod probe. We're only running mod probe in the module loader. And does it make sense to restrict what mod probe can do if at the same time you're loading something into kernel space that can do whatever it wants afterwards? And we were thinking about that in the context of researching if we can create those custom SE Linux policies and deploy them to the node. And what we see is that there is a huge overhead in doing that. There is a SIG node project that is the security profiles operator. That is something that you can install and that will deploy a custom policy on all your nodes. but that is something additional. And what are we going to prevent in this very case on the module loader? That's the question I have.
You know that and so I think that the first thing is that the motor node maybe needs some permission that we know that we have to give the KMMO the permission to load the module, and maybe there are some other operation we need to assign. So I think that at least that I think that we should. I agree with that that we should firstly figure out what the permission we need to assign to the user, and then we should define the policy. And then maybe I'm not sure is this related another topic about the security, the interface, security attack. Security attack evaluation. I forgot the name. So normally every project gonna have this kind of security checking to check all the interfaces that the potentially will be leveraged by the hacker to hack the system. I forgot the name, so that's a special name for that. It's used to evaluate all the interfaces that exported by the project that potentially can be leveraged by the user. So I think that we should also do that things in the KMMO and to evaluate all of their interfaces and the permission we assign to the user. And we need to verify one by one whether this kind of interface is secure enough and can be leveraged. And if we find some potential issues, we can use the policy to prevent that. So, and I totally agree with you that we will not only just fully hope that you guys can do that. I think definitely we should go ahead to work on it. To firstly that.
Absolutely. I think the security model or the security principle of KMM has always been that, if you're able to create a module, it means that you're able to insert kernel modules on your node. It means that this is a very privileged operation and that only the admin should do that. Because effectively, we have no way of restricting what the module ultimately will be able to do. Once the module is in the kernel, it's game over. It can do whatever it wants. So what we have to do, and I think that's already in the manifests of KMM, is that we have a role that you can give to your service account, and that service account will be able to deploy or alter module CRs, and only users with that role will be able to do that. And I think it's we can work further on that, but I think it's rather a matter of documentation, specifying that users should be very careful about to whom they give that role, because it has consequences on what service accounts can deploy on the nodes ultimately.
Yeah, I in general, I agree with you that if we install the module and the module can do everything in the kernel, right? But I don't think that even module can do everything in the kernel. I don't think that we should ignore the security checker on the KMMO side. I think the KMMO side, we need to do our things good to provide the security mechanism. But for the module itself to do everything, I think it's the module's problem, right? Module owner need to make sure that they don't do anything bad to the kernel. That is another layer operation that duty. But for the KMMO side, we need to make sure KMMO side is safe enough. We will not allow the other permissions privilege for the user. And I totally agree with you that we need to add some documentation to remind the user. But that's not enough. I still think that we need to provide some mechanism in the KMMO level. And even I think that we should also at least to figure out a standard way how to check out security topic in the project. Security topic is always important. I mean, from the beginning of the project, I think a lot of upstream projects have that part of efforts, right?
Sure. So
And
one thing.
we will definitely work on it. Yeah, except for the feature itself, this part. I think today we just use one specific issue to raise up this kind of security topic in this project.
All right. All right. So I'm thinking about the action items that we should take here. I think one, as we agreed, is documentation. Maybe another one, if you think that makes sense, would be to try and find a policy that is much more tightened, that would only allow sysmodule.
I think the first thing is documentation. The second one is I remember the approach is called attack interface evaluation. So this kind of I can send out the former name. I've suddenly forgot that. So this kind of the general approach to that's a long time process to go through to check all the interface exposed to the one project and track that whether there's some potential risk in the interface. Right. Yeah, I forgot the name, but every project should do that kind of process. And then after we go through this check, we find okay, there are some interfaces that are quite easy possible to be leveraged by the user to attack their system, and then we can find some of the way to restrict this kind of prevent this kind of risk. And then this kind of SE Linux mechanism is one of the standard we used by OCP. Of course, I know in the upstream, not all the system enables SE Linux, but for the people who use the SE Linux, we can use SE Linux to enhance the security. But I think there's also some other mechanism in the kernel can never to do the same thing. So we can continue to. So first thing is that document it and then scan the potential risk and then find a way to strengthen our security. So that's the approach. And then SE Linux is one of the approaches to strengthen our security.
Right. I hear that you would like. In fact, yeah, this attack interface evaluation would be a way to formalize the security model. Is that right?
That's true. Definitely.
Okay. I think that makes sense. And as soon as we start working on documentation, which we should do very soon, then we should indeed come look at that. Yeah. And you said that there was user container Linux. What is that? Okay. So that's
right. That is actually that's I think how to say that. You can also check the container as in Linux. That's another project. It's very similar. This one is our project. We're gonna define our layer tiered policy, and then after this one is and then at the same time we will also push this one to the OCP through the container SE Linux project.
Okay, so okay. Let me have another look at that offline.
Okay, cool.
Yeah, one quick thing I would like to add is like I was trying to play with this thing, but it looks like there is no build instructions on how to build the system. So the requirements and stuff, I was not able to build it. So is there like a build instructions for the project?
You mean the KMMO OCP project, right?
Yes, KMMO, sorry.
You want to build KMMO for OCP?
Yes. Is it possible?
You shouldn't need to build it yourself, in fact. If you look at getting started here, this actually should work.
Yeah, I mean, but I wanted to like modify some Go files and like play with it. Like
actually that we managed to try to work on using some predefined SE Linux policy on the project, because this one is specific to OCP, right? So we want to start our SE Linux policy work from this project. So that reason many should want to change the code and have some test on it. If you think that we can also do it on the OCP, on the KMMO project, you can maybe we can also start from there. So, any suggestion?
I think so. I would start upstream, even though, you know, as you said, not all distributions are using SE Linux, but I would probably start upstream and see what it looks like, really. And going back to your question, Manish, I think you could. Okay, I don't remember the commands by heart, but there is. You would have to use the make file. If you want to build the image, that's something like make docker build, I believe. Exactly, and then make docker push. And then you would create your own image of KMMO for you to deploy it in a cluster.
Okay, thank you. Yeah,
there's also make deploy. I would encourage you to ask a question on the Slack channel, and we can assist there.
Okay, thank you.
Oh, thank you.
Right, so I have taken a few notes. I will populate them in the document afterwards, if that's okay. Okay, so thank you for the discussion on that topic. Any other comment on that topic? If not, then I would move to the next item in the agenda, and that's another issue created in the downstream repository, and that is removing a kernel module as a prerequisite. So here I understand that you would like to unload the in-tree module before loading the out-of-tree one. Is that correct?
Yes, that's the issue we are having. Yeah. Currently, we are doing manually, but we would like something more automated, like.
Right. Somehow I think this goes together with the feature that we have to copy the firmware files on the node. This is another operation that we do before loading the kernel module, and this sounds a bit similar to that. And to copy the firmware files on the node, we actually transform the modprobe command into a shell inline command. And
yeah, I agree with you that in the beginning, I think in the very beginning, so KMMO module CR can have the interface for user to specify their way how to prepare the system and how to install the modules and driver into the kernel. But looks like now the mode probe has been embedded into the module itself, into the KMMO itself, and only provide some predefined interface for user to specify their parameter for mode probe to use. But you know that using just install the module into the kernel and make the whole system work is a very ideal situation in the real environment. So normally, when we try to before we try to install the kernel module, normally we have to do some customized operation, right? So firmware is a setup, is a one example. That example is that for our case, this case is that since that our driver, need to out-tree driver, since you know that although our driver is out-tree, but sooner or later, eventually, we are pushing our driver into main in-tree. So that reason, currently there's already has an in-tree driver there. So in order to us to install our driver, we have firstly to remove the existing in-tree driver and all the other drivers that depend on this in-tree driver, and then we have a clean environment to install our drivers. So which means that in this situation, if only use the mode probe, that's definitely not enough for us. So I hope that it is great if you can, except for, so firstly, we are very like the kind of is defined that finalize the hide the mode probe detail from the user. That's good. That's very good. I like that approach. But except for that, it is great if we can also define our exposer interface for user to do some customized operation before we do the mode probe. That's going to be a fantastic for us.
And I've been thinking about this, and together with the firmware feature, I'm trying to think that it's a lot, and in the pre-start and post-start lifecycle hooks, we don't want to chain shell commands like that. So I think our best approach to this is to have a small binary that behaves a bit like mode probe, but that we could configure with a few parameters, such as, okay, we want you to load that kernel module, but before you will have to unload that one, and you will also need to copy those files. And I'm thinking that this small, fairly simple binary could be shipped with KMMO, and it could be a base for all the driver containers.
It's good to ship some binary, but you know that firstly we have to define, we have to anticipate the real usage case and the real situation. You know that the real world drivers quite have a lot of strange behaviors and operation need to do before make the mode the driver. So I still hope that we can provide some hook or pre or post install module interface for user to add their own script, to run their own script or binary before they install mode or mode probe the driver. That's more flexible, right? Because we never know that what's the requirement for each driver before they know the driver into the kernel.
Right. I hear what you say. I'm wondering if we should allow. I'm wondering what amount of liberty we should give to the admin here, because I agree with you that okay, it's fine to provide hooks to people and maybe to execute all the scripts in a given directory, for example. But I'm afraid that this could be abused to start applications and do this kind of stuff, and then we end up in a situation that is similar to that of SRO back then, and we really want to avoid that. We really want to keep a clean design. So I'm wondering what would be the right approach to this.
Yeah, good point. Totally agree with you. Yeah, I think we should find a way to carefully design that. I totally agree with you about that. It's going to be abused by the hackers, by some malicious users. You're right.
Let us stop. Let us think a bit more about this, and maybe we can kick off a conversation on the Slack thread to gather more input on the best way to do that.
Okay, good. Yeah, agree.
Or maybe someone today has an opinion that they want to share. If not, then we can discuss around that issue on a Slack thread. I understand the usability concern, and I think it's a valid use case. Unloading the in-tree driver before loading the out-of-tree one. But at the same time, as I said, I would like to avoid that KMM becomes a free-for-all where you can just run anything in the container.
Agree. Totally agree.
We want that to remain healthy. Great. I think these are
Quanti, I also suggest that we can make full use of this kind of GitHub issue mechanism, since that Slack is not easy to track. We can discuss Slack, but Slack is not easy to track the progress and decision. And I think that except for the Slack, we can also use the issue here to discussing. So, and then we can easily to track this issue, right?
Yes, sure, absolutely. Absolutely, but I would ask you guys to create issues in the upstream repository instead.
Okay.
If that's
Okay.
because development happens there,
Okay.
and then we cherry pick the features into the OCP edition. But really, like the the bleeding edge is in the upstream. So I'll
Cool.
try to see if I can move those issues.
Let's do that. Let's do that. Manisha and Hirsch, please move. We can refine issue in the upstream. Yeah.
Will do.
Okay.
Yeah. I think that we should continue to follow the upstream first policy. Yeah.
Yes, please.
Yeah.
Yeah, and I think both issues here qualify to upstream issues.
Cool.
Also SC Linux, so it all makes sense.
Cool.
Right, that's all I had on the agenda for today. Maybe we can discuss, since we have a bit more attendance today. Maybe we can discuss about that item that I had, and that is, should KMM remove its labels when it is uninstalled? You know that KMM is adding labels to the nodes with their kernel version, and that is used internally for the scheduling of the daemon sets. Now, to removing those labels whenever KMM is installed is not easy from the perspective of OLM or from any other perspective, really. When killing the removing those labels when killing the operator is not straightforward. So we're wondering if someone is actually annoyed by this or feels that we should actually remove those labels.
I think I can give some share some experience when we're working on the NFT. Actually, that NFT, we find some issues that really, when we're using NFT, we find some issues that really puzzle us. Is that NFT sometimes, I'm not sure all the NFT have this issue, but sometimes when we're working on the NFT, we find that NFT sometimes set the label, and then after we remove the NFT, and the label is not removed and not be updated, and still there. But
yes.
but the problem is that after we remove the FD, the lobby is actually the label is not being managed anymore. But you know that the other component and service do not know that at all, and they still feel that okay, the module is still there and the label is still managed by somewhere else, and still continue to use the label to do something. That make us a lot of problem, very headache problem. So that reason I think that it is great if we find okay, this label. First, we need to figure out, okay, this label is only managed by KMMO. If that's the case, after the KMMO is removed, we should remove that. In case that so I think we can call it some kind of basic problem.
So you feel that we should remove it?
Yeah, I feel that we should remove it, but maybe we should case by case to check each of the label.
So in fact, it's only one, really.
Only one.
I believe it should be only one.
I think that we can start to remove it to find what problem is going to come. But I know that if we do not remove it, that's going to have some problem.
So in fact, the label that KMM adds to the nodes. I'm wondering if we should have that conversation. Let's have that conversation now. So KMM adds several labels to the nodes. The first one is the kernel version. It adds that label to all the nodes that are present in the cluster. And it's the only component that uses that label. So I would be tempted to say if we leave it, that's no problem.
So what's the label again?
The kernel version.
Kernel version.
The kernel version of the node is in one of the labels of the node. We put that there.
I still strongly suggest you to remove that. Seriously, because if we leave a label that no one gonna look after it, it's gonna make the system in an inconsistent state, and also that label will confusing the other component.
I agree that they might be confusing the user, but they are not putting the system in an inconsistent state because no one else is using that label.
You will never know that.
Well, no one else should.
Yeah, so you know that someone gonna find, okay, I want to know. So you know that some of the user might check, okay, I want to check their kernel mode. Oh, that's a label there, so I'm going to use it. No one knows that.
Right. And then the second type of labels that KMM adds to the nodes is that whenever a kernel module is loaded on the node, then we label the node with the name of that module. And so when the module is unloaded from the node, then KMM also unlabels the node. So is there a possibility that we still end up with the module name on the node once it's removed? I don't think so.
Well, this one still need to check the states. If the user, I mean, some of the other system want to check their status of their label to verify whether the mode is loaded or not. So even that even the KMMO is removed, but the driver KMMO. Okay, so let me ask another question. So for this situation, if the module is KMMO is removed, the module will also be removed?
No.
Okay, if the module is not removed and the label will also still used by the other service to check whether the module is there, and then I think maybe we still need to leave it.
In that situation, though, you would remove the controller, the KMM controller. It would automatically kill all the daemon sets. But it's true that I can see a situation where we don't remove the module name from the labels. Okay, I think that we can have a deeper discussion under an issue. And we have an issue upstream, actually.
Okay, yeah. Let's talk that. I think that we are also quite interested in this because, frankly, we are puzzled by the label things a lot in the previous works. Because the label in the system, actually, I can feel that in the Kubernetes or OCP platform is abused sometimes.
Right. Okay, let's keep thinking about that. If you want to add some input under that issue, that would be welcome. Okay. It's an upstream issue about removing the labels. Mm-hmm. But I have taken some notes and I will add them to the agenda document. Mm-hmm. Great, thank you for the input. I think that brings us to the end of the agenda that I had for today. Any comment, remark, or question from anyone?
Also, the canary deployment, I think that maybe Chaitanya has some comments in the.
Yes. So this is about the first two topics in the action items. So we just wanted to update that we are starting to work on a CI KMMO CI pipeline where we will try to automate the driver build process and release process. So here as a part of automation, we would like to get ideas about how to do some of the sanity checks during the build process of the drivers. And once the drivers are built, we would also like to do some canary deployment to test the driver deployments, driver loading. So we just wanted to update or maybe start a discussion over there that and get some ideas from the community, like if anyone is working on the similar tasks or what are the ideas about the same. So
yeah, actually that we have from the user KMMO user point of view, we have a big picture for us how to use the KMMO. You know that for the KMMO, firstly, we have to regularly release the auto tree driver, right, on the OCP platform. Maybe on every time once the OCP upgrades their kernel, right, kernel version, we have to rebuild and release and retesting the auto tree driver. It's a huge burden for us to do that. So and what we are thinking is that we're gonna make use the KMMO as a key technology, and then combine some other automation framework, and try to first thing we need to check whether the OCP kernel version changed. If it's changed, we can trigger the KMMO to start to build the driver according to the new kernel, and then we're gonna leverage the send task and the canary deployment task to verify the new built kernel. Driver container images, and if that image has go through this kind of send task and canary task, and then we're gonna kick off the official pipeline to do the certification and then release it to the OCP platform. So we hope that as I said, we want to make use of KMMO as a key technology to kick off this whole building, releasing, and testing process. We also call it the CI/CD pipeline. So it's gonna be a big picture. That's the reason we didn't have any updates in this topic. So I think that internally we are still trying to figure out all the detail, and we're gonna work out the whole picture, design or proposal. I think that if we are ready, we can share that to upstream, and we want to get feedback from upstream. And so at that time, the canary deployment and send the test are all part of that approach.
So you will come up with a solution or an idea for that canary deployment?
Yeah, it's actually that we're gonna make use of the KMMO operator as a key technology to work out something internally we call is a CI/CD pipeline to build and releasing and certificating the out-of-tree driver container image automatically. So we hope that I think that's not directed with KMMO operator, but that is the way how we use the KMMO. I hope that we can present that as a whole picture to the upstream, and we want to gather some feedback from upstream. I think we can. Well, hopefully we can present that maybe in the following 2 weeks someday.
Well, that sounds great. I also hope that you can present that. I was actually, give me a minute here. I was just checking. Okay, 2 weeks should work. That sounds great. Yeah, I'm just wondering about some of the specifics, but if you guys are already working on something, then I would wait for like the big picture or the presentation before I ask my questions.
So maybe I want to add share one more information. Actually, that even the KMMO hasn't been official to a release, but we already start to use it. We already start to use the KMMO internally to build and deploy our Intel DGPU drivers, because our Intel already released the data center DGPU hardware, which called Flex, right?
That's really great to hear.
And we have and this, especially these two issues, all come from that efforts. Especially the second one. Yeah, the second one actually is, I can say that is a block issue for us, since that we cannot, with the current approach, we cannot remove the existing entry driver that block us to use it. Now, in order to use it, we manually to do that.
So you mean that one, right? Not in the actions, but like 64 here. All right. Let's work on it. Let's think about what we can do here. I mean, we still have a lot of items on our roadmap here before GA.
I know. Fully understand. And we also are highly depend on you guys to release GA. But we, as I talk with Bertrand, a lot of other guys, is that we are not just wait you guys to release GA and use it and suddenly find, okay, there's a lot of issues that cannot meet our requirement. we're gonna go together with you guys. When at the same time we can always use the latest, even not the final release. We're gonna continue to use it and continue to give you feedback.
Yes, please. Absolutely. Okay, so I look forward to your CI/CD pipeline idea. Maybe it can inspire us, like for this canary deployment. Also, I'm just thinking about some label-based thing to, like increase or decrease like fleets of nodes in the cluster. But I couldn't find any off-the-shelf solution for that. So let's see what you can come up with.
Yeah, you're right. Even the labels that we also think about labels, because that we only use the KMMO to build the IoT driver. So after the driver is molded, and we also need to check whether it works properly. Only when it works properly, we can export some kind of label to let the other systems that the module work properly, and then our inter-device plugin operator can go ahead to enable the device plugin to do the following job about basing on the driver. So that is going to be another topic you need to cooperate with other system module service. I think we have a lot of interesting topics ahead of us.
Yes, but hopefully to deploy your device plugin, you can leverage the label that contains the module name whenever it is loaded, because that is what KMMO uses.
We have to make sure that the label is loaded right. We have to make sure that the driver is really work. Sometimes it's loaded, but it's not work, right? So it's going to be share the risk and burden to the up layer, right, to the other services. And also, we also know that there's some receipt problem, right? So you know the driver, but it will take the driver and hardware some time to really get ready. Right? You know the driver, between you know the driver is loaded and the hardware ready, there's some time, some gap, right? Some time gap.
Yes.
Yeah. So if you load driver and set label and all the other operation continue to use their driver, that's definitely going to cause some receipt issue.
Yes. And we should try to find a way to mitigate that without opening too many doors. I think it's the same kind of conversation that we have for issue 64 right here. Giving the admin some or the driver container vendor some liberty without opening the Pandora box to just anything.
You're right. I agree with you. Yeah, Westside. That's also the reason why we find the first issue. The things that we need to assign some permission to user, but we don't want to open the Pandora box. That's the reason and actually the SE Linux is one of this kind of box. We want to have this box, but we also need to open open the box a little bit for the user. It's not easy, but we have to do that.
We will sync with the SE Linux team at Red Hat to understand what exactly is the situation here and see what we can do with with the project you linked.
Yeah, and then I think that I can do that. Dan working very closely with us, who is the SE Linux container policy, SE Linux container owner, so we can work together closely on that.
Sounds good. Sounds good. Any other topic? We have 7 minutes left. Any other topic from anyone? If not, then I propose that we close here for today. Yep, let's close. Thank you very much for the great discussion and for all the work that we're doing together.
Thank you.
Thank you.
Thank you all.
Thank you, Brad.